Hello everyone, welcome to my calculus lecture. In this lecture, we continue to study L'Hopital's rule. So the last thing we want to talk about is the indeterminate form 0 to 0, infinity to 0, or 1 to infinity uh, type. If f of x to the power g of x, okay, so this type of function assumes the indeterminate form 0 to 0, infinity to 0, or 1 to infinity at x equals a, or at x equals plus or minus infinity. The limit of this function f of x to the power g of x when x approaches a, or limit of the same function when x goes to infinity or negative infinity may be found by writing y equals f of x to the power g of x uh, and investigating the limit approached by the logarithm ln of y equals g of x ln of f of x. If limit of ln of y when x approaches a is k by the continuity of y, okay, so that we can find that we find that limit of y when x approaches a is gonna be e to the power k. Okay. uh, the reason for that is when y is continuous, right? Remember, by one of those like properties of continuous functions, in fact, the logarithm, right? So that leads us to this limit here, right? Okay, so we're gonna work on each example, okay, one at a time. All right, so to work on this example, let us first work on the limit of x to the power x when x approaches 0 from the right side, okay? So right-hand limit of x to the power x at x equals 0. Okay, so we are going to get to my notepad. Okay, so first step is we set this function x to the power x equal to y. Okay, and then we are going to take the logarithm each side. So ln of y equals ln of x to the power x, and by one of the properties of logarithm, this exponent, right? X is an exponent of x can be brought in front of a logarithm. Yes. So that this equals x times ln of x. Okay. Now, so we are taking the limit of this first. So limit uh, x goes to 0 from the right side. Uh, x ln of y equals limit x goes to 0 from the right, x times ln of x. So x goes to 0, and when x approaches 0 from the right, ln of x goes to negative infinity, right? That's clear from the graph of ln of x, right? So if we disregard this the sign part, this is again 0 times infinity type, okay, indeterminate form. So in this case, we will have to rewrite, okay, so there are two ways you can do this, okay, uh, you know, so I'm going to use different color. So, the x times ln x can be written as, for instance, uh, x over x over 1 over ln x. Okay, so in that case, this is going to be 0 over 0 type. So, the writing x times ln x in this way, right, you can convert this indeterminate form into 0 over 0 type. However, if you attempt to apply the L'Hopital's rule, you're gonna, face, the problems, because this part here, 1 over ln x, right? So if you take the derivative, the uh, the uh, the result is going to be like more complicated function. So that's not gonna lead you anywhere. Okay, so you can easily see that, right? So this is not a good idea. Okay, not a good idea. Okay, not good. So we are going to do the following. So write this as ln x of over ln x over 1 over x. Okay, 1 over x. All right, so in that case, this whole thing becomes infinity over infinity type. Still, this is the indeterminate form where we can apply, uh, the L'Hopital's rule, right? So by L'Hopital, uh, this equals the limit x goes to 0 from the right. The derivative of ln x is 1 over x over 1 over x over derivative of 1 over x is going to be negative 1 over x squared. Okay, so that will be limit with the little algebra, this becomes negative x, and what do you see? That equals, 0, right? Okay, so limit of ln of y when x approaches 0 is going to be 0. Therefore, remember earlier, we were mentioning about the how to find the limit. So from this limit of y, okay, limit of y when x approaches 0 from the right side, uh, again, due to the continuity of a logarithmic function, okay. Oh, I think I might have misspoke, earlier. Uh, I hope I didn't, but in case, I feel like, I misspoke. The It's not due to uh, the continuity of the y continuity of logarithmic function. Okay, so if I did, I apologize, I misspoke. So due to continuity, okay, we know that logarithmic function is a continuous function. So due to the continuity of a logarithmic function, this limit can go inside the continuous function, which is a logarithmic function. Okay, right? And so, in fact, right, why don't I actually, write down like little details, okay? Right, so limit of ln of y when x goes to 0 from the right side equals because of again, let me repeat that, okay? To emphasize because of the continuity of a logarithmic function, okay? Continuity of logarithmic function, right? This equals ln of limit of y when x approaches 0 from the right side. That's one of the properties of, okay, of continuous functions, right? So, because this logarithmic function is continuous, okay? That's continuous. Okay, so that equals, what is that? 0, right? That equals 0. We just calculated that. The limit of ln of y when x approaches 0 from the right, that equals 0. So, the limit of y when x goes to 0 from the right side is given by, you know, e to the 0, which is 1, right? Okay. By the way, you might be wondering why, like, I'm considering only, the right-hand limit of this original function, right-hand limit of x to the power x at x equals 0. The reason is clear. Here, remember the ln of x, right? Ln of x case, the ln of x, there is only one-sided limit exists. If you, uh, look at the log function, okay, it's clear that you can only consider right-hand limit as 0, but there is no left-hand limit. Uh, the That's the graph of ln of x, right? So when x equals 1, y equals 0, right? It's passing. So as you can clearly see that when x approaches, right? So limit of ln of x when x approaches 0 from the right side, right? ln of x goes to negative infinity, okay? It keeps falling, right? Getting close to y-axis. However, there is nothing, okay? No part of ln of x, exists on the left side of 0, right? So, there is no, left-hand limit at x equals 0. Because of this, right, we only consider the right-hand limit of this function here. Okay, next example is limit of 1 minus sine x to the power 1 over x when x approaches 0. Okay, so we're gonna work on that. Limit x goes to 0, 1 minus sine x to the power 1 over x. Okay, so here you see exponent of 1 minus sine x, which is 1 over x, right? Now you know that 1 over x, the limit of 1 over x when x goes to 0 does not exist. Okay, right? We talked about that earlier. So because of that, we have to consider, the two separate limits. So we will have to consider what is that, right-hand limit and left-hand limit, right? Separately. So if their values are the same, then limit exists. Okay, so that's what happens. So first we are going to consider limit of 1 minus sine of x to the power 1 over x when x goes to 0 from the right. Okay, so right hand limit. Okay, and in this case, you can see that when x goes to 0, this is going to be 1, 2. So this whole thing is going to be when x goes to 0 from the right, Okay, sine x goes to 0, 1 over x goes to infinity, right? So this is actually 1 to infinity type, okay? This 1 to infinity, again, this is not 1 because this number here is actually, the one you are seeing as 1 is not a number, okay? It's not a number. This is a state which is very, very close to 1. Unfortunately, we are just using same symbol as number 1, but this is not a number. Remember, that's why it is 1 to infinity. This whole thing is an indeterminate form. It is not a number. Okay, right. So we don't know what it is yet. Okay, so we gotta work it out a little further to figure out what this limit is going to be. Okay, so in this case also we are going to use the same method. So what we are gonna do is the set y equal to 1 minus sine x to the power 1 over x, then ln of y is going to be 1 over x times 1 minus, sorry, I forgot ln, right? So it will be ln of 1 minus sine x. Okay, so now we are going to calculate the limit of ln of y first, like we did in the previous example. X approaches 0 from the right side, so that equals limit x approaches 0 from the right side, 1 over x, right? 1 over x, ln 1 minus sine x. Okay, let's see. When x goes to 0 from the right side, 1 over x goes to infinity. On the other hand, the sine x goes to 0, so this whole thing, ln part goes to 0. So this is infinity times 0 type indeterminate form. Okay, so in this case, we write this as actually this is one of those easier cases. Let us write this as ln of 1 minus sine x, right, over x. So what do you say? Now what you are saying is, this limit is 0 over 0 type indeterminate form, where you can apply the L'Hopital's rule, right? L'Hopital's rule directly. So that's what we are going to do. So next step, okay, I'm going to use L'Hopital. derivative of this numerator, right? That is 1 over 1 minus sine x, and then you have to multiply this by the derivative of inside the parentheses, right? By the chain rule, that's going to be negative cosine x over derivative of x. That's simply 1, right? So it's just like that. So we have a limit x goes to 0 from the right side. The negative 1 is constant, so I can actually pull it outside of the limit. We have a cosine x over 1 minus sine x. Okay, so when x goes to 0, what happens? When x goes to 0, the sine of x goes to 1, right? And I'm sorry, cosine of x goes to 1, and sine of x goes to 0. So, the 1 minus sine of x goes to 1. So 1 over 1, that becomes 1, right? So this is going to be negative 1. Okay, so what we have here is that uh, this limit of ln of y when x approaches 0 from the right side is negative 1. Okay, negative 1 here. Therefore, by the same argument earlier, right, using the continuity of a logarithmic function, we find the limit of y, which is this function, right, the original function, when x approaches 0 from the right side, that's going to be e to the negative 1, this value. Or you can write this as 1 over e. Okay, so that's going to be our final answer. Well, not quite yet, all right? Not quite. We just calculated, the only like what? One-sided limit, right? The right-hand limit. But it turns out that, okay, I'm gonna leave this to you, right? So, you can easily check. Really, I mean, those are the same steps. But similarly, okay, similarly, so by doing the same calculation, pretty much, right? We also find that the left-hand limit of y, when x goes to 0 from the left, that is also e to the negative 1. Okay, or 1 over e. As a matter of fact, you can clearly see from, you don't even have to like, to start over again. Like, you just, to follow, right, what we wrote here earlier, okay? You get all the same thing. Just replace, the 0 by, 0 positive by 0 negative, okay? But even in that case, also, the cosine x is continuous at x equals 0. So limit exists at x equals 0. In fact, the left-hand limit, right-hand limit, same. So, it's going to be 1. The same for sine x. Left-hand limit, right-hand limit at x equals 0, both equal to 0. So you end up getting the same the value, negative 1, and hence we have this. Okay, so simple as that. So since the right-hand limit and left-hand limit are the same, therefore, right? So therefore, limit of the original function, right? 1 minus sine x to the power 1 over x when x approaches 0, that equals 1 over e. Okay, good. Okay, now uh, let's take a look at our last example. So limit of 1 plus x to the power 1 over x when x approaches 0. Actually, this is what? Very famous limit, okay? We talked about this limit some time ago. This is a limit that defines what is that? The, the very important number, right? E, okay? So in fact, this limit equals E, right? So we talked about that. And we are going to actually show that, the limit of this is going to be E. So here's the next example. And our last example, limit of 1 plus x to the power 1 over x when x approaches 0. Okay, right. So, well, again, we already know the answer. This will be E, right? So we are going to actually calculate that. Since again, we have what presence of 1 over x, right? Presence of this 1 over x. So by the same reason, we will have to consider right-hand limit and left-hand limit separately. So first we calculate limit of 1 plus x to the power 1 over x when x goes to 0 from the right. Okay? Right, so this one here is what? Again, when x goes to 0, this is a 1 to infinity type, right? 1 to infinity type. Okay, so what we are gonna do here is, the set y equal to 1 plus x to the power 1 over x. Then, the ln of y is going to be 1 over x times ln of 1 plus x. Okay, so we are going to calculate the limit of ln of y first. Okay, so we are going to calculate limit x goes to 0 from the right side, ln of y, which is limit x goes to 0 from the right. I'm gonna actually go ahead and write that as ln of 1 plus x over x. And what we have here, when x goes to 0 from the right side, this whole limit is going to be the type, when x goes to 0, this is going to be actually 0 over 0 type indeterminate form, right? In which case, you can apply L'Hopital's rule directly. So by L'Hopital's rule, okay, L'Hopital, by L'Hopital's rule, this is going to be same as limit x goes to 0 from the right by taking the derivative of numerator and the denominator separately, right? We have the top part, we have 1 over 1 plus x, and the denominator, derivative is 1, so this is all that's remained, right? And when x goes to 0, this becomes 1. Okay, so this implies that, again, using the continuity of a logarithmic function, right, we find the limit of y when x goes to 0 from the right side, that equals, that's given by e to the power 1, which is a. So we find this, right? And in fact, similarly, if you follow the same steps, here, okay? So, when x goes to 0, negative case also, in that case, ln of x goes to 0. I'm sorry, ln of 1 plus x goes to 0 when x goes to negative infinity, and also, the x goes to 0 when x, approaches 0 from the left side. So, even in this case also, we end up getting the same thing, right? 0 over 0 type. And then by L'Hopital's rule, we get this when x goes to 0 from the left side, right? Still we get 1, right? So actually, by the following these steps, you also have, I'm using actually different color here now, we also find, right, limit of y when x approaches 0 from the left side, that equals e as well. So that since right hand limit and left hand limit are the same, therefore limit of this guy here when x goes to 0 does exist as the number e. So we just showed that. Okay, folks, more details of it, my discussion here can be found in my lecture note at the following address, right? So as usual, this is a hyperlink. So all you have to do is click on this link and it'll take you to the my lecture note. And also, if you are interested in visiting my main blogger site, just click on this word, the blogger, which is hyperlinked. So it'll take you there as well. Okay, so thank you very much for listening and watching my lecture. Goodbye.